questions 11 through 20 on the 2002 Grade 8 Gauss Math Contest. A palindrome is a positive integer whose digits are the same when read forwards or backwards. For example, 2002 is a palindrome. What is the smallest number which can be added to 2002 to produce a larger palindrome? So 2002 is a palindrome. So what's the next palindrome if you were to go in that order? Well, it would be 2112. That's the next one. So what do you have to add to 2002 to produce 2112? Well, a simple subtraction question. 2112 minus 2002 is 110. So you'd have to add 110 to 2002 to get the next palindrome. So therefore 11, the answer is B. Which of the following can be folded along the lines to form a cube? So this is a cool question, involves a little bit of visualization. And let's talk about each one. So choice A, if you were to fold this up, you might think, okay, that looks pretty promising. But the problem is that you're going to get two tops. So for example, when you fold this side up, this square would become the top. But if you fold this side up, this square would also become the top. So you'd have two tops and there'd be one side missing. The next one, that can't be made into a cube. It's fused together in such a way that the cube would not be possible. In a very similar way, C is also two fused together. You need a lot of individual flaps to happen, and that can't happen with C. D, well, D looks promising. These two can be folded up. This two can be folded up. This becomes the top, and this would become the very final side. And that is the answer, but let's just talk about E. E, you would get overlaps, basically. This one would overlap with that one. So the only one that works is D. If A plus B is 12, B plus C is 16, and C is 7, what is the value of A? So they give you C is equal to 7, and then they tell you that B plus C is equal to 16. So B plus 7 is equal to 16, so therefore B is equal to 9. So then B equals 9 can be substituted into this formula to find A. So A plus 9 is equal to 12, and therefore A is equal to 3. So number 13, the answer is E. In the diagram, ABD is equal to BDC, and DAB is 80. Also AB equals AD, and DB equals DC. The measure of BCD is. So let's start talking about this diagram. We've got 80 as that angle. And they tell you that this and this are equal. AB is equal to AD. They tell you that, and then they also label it. So that means that's an isosceles triangle. So that means that this is the same as that in terms of the angles. So we can use the fact that all the angles add up to 180 to figure out x. So this becomes 2x is 100, and therefore x is 50. So that's 50, and that's 50. And now they also tell you that ABD, this angle in here, is the same as BDC. So BDC is right here. So that helps. That's already 50, so that means that's 50. And finally, they tell you that DB is equal to DC. So this is equal to that, and they've also labeled that. So therefore, this is an isosceles triangle, BDC. And since that is isosceles, these two angles are the same, so I'll just call them y. And therefore y plus 50 is 180, and therefore 2y is 130, and y is 65. And what angle? BCD is what they want. So BCD, so they want this angle, and that's 65. So the answer to number 14 is A. A perfect number is an integer that is equal to the sum of all of its positive divisors except itself. For example, 28 is a perfect number because 28 is equal to 1 plus 2 plus 4 plus 7 plus 14. And these are the positive divisors of 28. Which of the following is a perfect number? So let's see, 10, its divisors are 1, 2, and 5, and the sum of those divisors is 8. So that is obviously not equal, so that is not a perfect number. 13, its divisors is just 1 because 13 is a prime, and the sum of its divisors is just 1. Remember, we can't use the number itself, so we can't use 13 as a divisor for 13. The next one, 6, its divisors are 1, 2, and 3. The sum of these divisors, 1 plus 2 plus 3, is 6. So therefore, the sum of all of its positive divisors except itself is equal to the number. So 6 would be a perfect number according to their definition. So number 15, the answer is C. 3 pennies are flipped. What is the probability that they all land and have heads up? Okay, so if you flip a coin 3 times, what are the possibilities? You can have all heads. You can have all tails. You can have 1 head and 2 tails. So you have these kinds of combinations: H, T, 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 H, T, and T, T, H. You can have 2 heads and 1 tail. So H, H, T, H, T, H, and T, H, H. And of course, as I previously mentioned, you can have 3 tails. So you have 1, 2, 3, 4, 5, 6, 7, 8 possibilities. And the one that we are interested in is when all land with heads up. So that would be this one. And there's only one way of doing that, so that's 1. So the total probability of this scenario is 1 over 8. So therefore 16, the answer is A. If p is a negative integer, which of the following is always positive? So we can just let p equal any negative integer. Let's say negative 5, right? Should work. So p squared becomes negative 5 squared, which is 25. 1 over p would be negative 1 over 5. 2p would be negative 10. P minus 1 would be negative 6. And p cubed would be negative 125. So which of these is positive? Only this one, p squared. Generally speaking, any number that is squared will be positive. So 17, the answer is A. When expanded, the number of zeros in 1,000 to the power of 10 is. So 1,000 is basically 10 to the power of 3. And then 10 to the power of to the power of 10, you multiply the exponents. So we get 10 to the power of 30. And this number basically is 1, followed by how many zeros? 30 zeros. So the number of zeros in 1,000 to the power of 10 is 30. So the answer to number 18 is B. The word stop starts in the position shown in the diagram to the right. It is then rotated 180 degrees clockwise about the origin, O, and this result is then reflected in the x-axis. Which of the following represents the final image? So first, let's look at what happens when you do the initial change, which is a 180 degree clockwise rotation. So first you go 90 degrees, so you go stop right here, and then you go another 90 degrees and end up here. So it will be something like this, like that. Okay? That's where it will end up when you rotate 180 degrees about the origin. And then we have to take this image of stop and reflect it in this x-axis like a mirror, basically. So let's see, the S will be like that, the T is going to be like this, the O is like that, and the P is, be careful here, it's going to basically be like that. See, you see how it's pointing up there? So it's got to point down like that. Now let's compare it to the answer choices. So we are basically here now. This is our final result. The first one, well, that's wrong because it's in the wrong quadrants. So A is out. How about B? Well, B looks like the right answer, but be careful. Look at P, the letter P in the word stop. Do you see how it's different? It's got the, I guess, the stem pointing upwards. So B is wrong. C, again, you might think, okay, it looks right, but again, for the same reason, P is incorrect. D, well, D, the letters are completely wrong. We've got S over here. And that by process of elimination leaves E, but look at E. The P is now looking like a Q, which is exactly the way we have it right here. So I think the challenge in this question was P, how to figure out how it looks. And therefore, number 19, the answer is E. The units digit, that is the last digit of 7 to the power of 62 is. Units digit questions are very popular on math contests. And the way you solve them is you look for a pattern. So first start with the power of 1, power of 2, like that. Make yourself a little list. And hopefully very quickly you should be able to get a pattern. So I'm just going to go up to 7 to the power of 8. Okay, so I'm going to just write down the units digit. Okay, so the units digit of 7 to the power of 1 is 7. 7 squared is 49, so the units digit is 9. 7 to the power of 3 is 343, so 3 is the units digit. All right, that's the only digit that I'm concerned with. Let's keep going. 7 to the power of 4 is 2,401, so the units digit is 1. 7 to the power of 5, you just keep going here. Units digit will be 7. 7 to the power of 6, units digit is 9. 7 to the power of 7, units digit is 3. 7 to the power of 8, units digit is 1. So I hope you can see a pattern here. It just keeps repeating, 7, 9, 3, 1. All right? So we are interested in the units digit of 7 to the power of 62. Now, how are we going to do that? Are we going to write it all out? Well, that's obviously not the most time-efficient way. So what we can do is look just at the pattern. Every time the exponent is a multiple of 4, the units digit is 1. So if we can get sufficiently close to 62 with multiples of 4, we should be able to figure this out. Well, first and foremost, is 62 a multiple of 4? And the answer is no, right? Because it'll be like 15.5. But what about 60? Is that a multiple of 4? Yeah, it becomes 15. So 7 to the power of 60 will have a units digit of 1, based entirely on this pattern. So therefore, 7 to the power of 61 will have a units digit of 7, and 7 to the power of 62 will have a units digit of 9. So you see how the pattern helps you? So therefore, number 20, the answer is D.